All right, so again, we're learning this a little out of order. You don't really need to worry about it until it's after the 4-1-4-5 test, but I just want to keep it kind of moving along. The first thing I want to do is sketch this graph on the calculator. So we're going to sketch two graphs, and then we're going to talk about a new vocab word, sinusoid. And we're going to do a couple of things with that. 4.6 is really small. It's not a super useful section, but we still look over it. We just spend a little time with it here. So when I go to 4.6 number 1 and I want to sketch y equals sine of x squared on the calculator, I'm going to put parentheses, I'm going to put sine of x, and on my parentheses, and then I'm going to put a square. And let's actually be in standard window. I have no idea what the last thing we graphed on these calculators were. So I'm just going to go to Zoom standard Z6. Ooh, and it looks kind of like a straight line. I'm going to promise that's not it. So we're going to zoom in a little bit closer. Can you remind me, normally sine goes as high as what and as low as what? Sine normally goes as high as, what's the amplitude for sine? 1. Good. So it normally goes as high as 1 and as low as -1. So let's adjust our window. So my y max, maybe it's just like -2 and +2, so we can see all around my picture what we're looking at. And then the other thing, I want to change my x min and x max. And let's actually look at the graph before we change our x min and x max. Okay, did I do something wrong? Oh, is anybody else's graph plot like this?
Yeah.
Okay, does anybody's graph look like a sine graph? Okay, the difference is, and I realized I changed this earlier and I forgot to change it back. If you are in degrees, it will look flat. That's not right.
Okay.
If you got to be in radians. So I'm going to be in radians. And now, okay, that looks more right. And so some of you probably were like, my graph doesn't look like hers. This is the more correct graph. Okay. The one other thing I do want to do is let's change our x min and our x max. Normally that's our like horizontal distance, our period. What's the normal period for sine? What is it? Let's get here. What's the normal period for pi? Or for sine, 2 pi, there you go. Good, we all should say that like loud and proud, 2 pi. So I'm gonna write 2 pi as positive and negative for my x min and my x max. So positive 2 pi for my x max, negative 2 pi for my x min. Now I should be able to see my graph a little bit nicer. Perfect. What's happening here is that a normal sine graph, remember, goes up and then back down. All that's happening is we're squaring my sine. So instead of coming back down, it goes up and then it bounces off and it stays up. So it looks more like a wave like that instead of going negative. Since I'm squaring that, all my values will be positive. So I'm going to copy my little wave over here. I go as high as +1. I'm going to hit my zeros at 2 pi. And I'm also going to hit my 0 at pi because that's where we're used to our zeros hitting, right? Are you guys okay with that? Sine normally has goes through the middle of the graph at 0, pi, and 2 pi. So instead of going down, we're just going to like be high, hit the 0, and then be high again. So little hills. You can also do this on the negative side as well. It's a little messy, a little shaky, but that's kind of proves the point. Okay. Now let's go graph the other one. Let's graph that y equals x squared plus 2 sine x. Okay. So y equals x squared plus 2 sine x. I'm going to keep my window the exact same, as high and as low as it was. And I'm going to go ahead and graph that. It kind of just looks like a parabola. Is that what you expected it to look like?
It has an x squared.
It has the x squared, so I'm not shocked, but this isn't really what I expected. I expected more of like a wavy graph. Let me make my y's a little bit bigger. So I'm gonna make my y max or min, I can see everything. So I'll make my x or my y max up to 10. So it's still a parabola, but it kind of like shoots off once you hit the origin. So it's something like this, and then it kind of like jets off to the side like that. So that was not really what we expected to see. But we could still graph them, it still works. Okay. Now, the next part of 6.1 is this new vocab word. It's the word sinusoid. Sinusoid means the shape or the type of graph that we have. I can spell that before. Type of graph, and it's that kind of waviness. Sinusoid means it looks like a sine graph, so it's a wavy graph. And in order for my graph or my equation to be sinusoid, I need both pieces to have the same period. Now, what was just happening before in our other graph is I have two pieces. I have x squared and I have 2 sine x. They don't have the same period. They don't have the same amount of space that it takes to like repeat a graph. And honestly, one's a sine graph and one's not. So those are not what we call sinusoid. So they would not make that kind of wavy graph as we saw in our picture. What we can do with the next 6 examples is we are just going to identify the periods of both parts of the equations. And if their periods are the same, then we're going to say, yes, those are sinusoid. It's just that simple. Okay, so let's go look at the first one, letter A. And I'm actually gonna get rid of my calculator. I don't need him anymore. Okay, letter A, I've got sine of x. What's my normal period for sine? 2 pi, good. And then I've got -3 cosine x. What would my period for that be? Is that your normal period or do we have to change it? Remember what changes it is my b, the number in front of x. Is there a number right here in front of x? Nope. So what would my period there be? I didn't know. I would be scrolling back through my notes, be like, what is the period of cosine? What's the period? 2 pi. Good. I swear I'm not trying to play with you guys. Sine and cosine, it's just 2 pi in general. If we have a b, then we change things. So 2 pi is kind of our stock answer we're going to always go back to. So if the period for the first one's 2 pi and the period for the second one's 2 pi, we would say, yes, these are sinusoids, and it's because they have the same period. Yes, because they have the same period. Okay. All right, let's go to letter B. What's my period for 2 sine x? 2 pi, good. The same as normal. All right, and then I've got negative tan. Ooh, that's different. We did tan just the other day. I'm gonna go back to my notes and see what did we say the period for tan was. Pi. Period for tan is pi. Would these two be sinusoid?
No,
No, what?
because they have different periods.
Good. Because different periods. And I'm not gonna say because ever again. I just like did a yes and a no example. So I want you to see why is it yes, why is it no. Okay. Let's look at the next one. I've got sine 2x. Ooh, I finally have a change to my period. Remember, we take our b and we do 2 pi divided by that. So 2 pi divided by 2 is just pi. So my first period is just pi. My next period, I do have a b there, it's 5, so I'm going to do 2 pi divided by 5. Is that the same thing as the period for 2 sine 2x? No. Pi and 2 pi over 5, not the same. All right, we'll do the last 3 together. What would my period for pi sine 2x be? Pi. What about for pi sine 3x? 2 pi over 3. Are those the same? No. All right, what about E in cosine 2 pi x? Well, that's kind of weird. What am I gonna, I'm gonna find my period by doing 2 pi divided by b. What's your b here? 2 pi, okay. That's odd, but you can still do 2 pi divided by 2 pi. What do we get? 1. And then I've got 3 sine 2 pi of x. I also have 2 pi again. What's my period gonna be for the second part of this? Also 1. Are those sinusoid?
Yeah.
Yep. Some hint that you maybe can kind of see already is that we're looking for them to have the same period, but in order for them to have the same period, they also should have the same b. So I'm looking like on letter C, I had a b of 2 and a b of 5. Those b's are not the same, so it's not sinusoid. On letter E, both my b's were 2 pi, so that's why it is sinusoid. And then we've got one more here. What would my period of the first part be? What would the period of the first part be? I'm hoping we're just shy and tired and not don't know. 2 pi divided by 2 is just. If you're being quiet and you're still following along, that's awesome. But if you have no idea what's happening, this is gonna be a tough year for you. It's a little too early to get senioritis. All right, and then the last part, what's my last period gonna be? 2 pi over 3. Are those the same? No. Okay. That was it for 4.6. Super short, super easy. All we did was graph things in the calculator and decide if they had the same period. That homework will be due, but not until the day after the test. So I truly don't know which day of the week I see you next week, whatever the day that is. Homework's due. Okay. We're gonna do sum of 4.7. I want to do 1. And then 2, and then 3, B and D, and then I'm done for today, okay? But before we get into that, I want to do a little bit of kind of side notes over here off to the side about this new unit. So in 4.7, the question says, find the exact value in radians, and it says sine raised to the negative first of root 3 over 2. Do you guys remember what that raised to the negative first is indicating? Like if I had f of -1 of x, do you remember what that's indicating? Okay, yeah.
Obviously, reciprocal.
You're getting close. The word I want is inverse. So one thing I've been like really, I don't know if you guys can tell, but I've been making like a really concerted effort all of this unit to not say that the inverse of sine is cosecant. I keep trying to say the opposite or the reciprocal. Inverse is when you like undo or you go backwards of a function. Remember that like f of x equals, I don't know, we'll call it like 2x minus 1. When we do the inverse of that, we switch your x and your y. And so we'll say like x equals 2y minus 1. Do you remember when we solved things like that back in chapter 1 earlier this year?
Yeah.
So essentially we like switched our x and our y to solve. We're basically doing that here. Okay. So if I think about that sine problem I just gave you, normally I've been giving you problems that say like sine of an angle equals some kind of ratio, opposite over hypotenuse, right? That looks familiar to us. However, to do the inverse, my answer instead is gonna be the angle, and we're gonna do inverse sine of my ratio, opposite over hypotenuse. In this case, my answer is my angle. Answer is my angle. Okay, so we're gonna use our unit circles for this. However, before we get into it, I got to give you a couple of rules. When we do inverse sine, it's only in 2 quadrants. When we do inverse of cosine, it's also only in 2 quadrants. And when we do inverse of tan, we also only care about 2 quadrants. I'm gonna sketch a little graph / show the unit circle to see why this makes sense. If the graph is not helpful, that's okay, you can ignore that, but I don't want to just be like, memorize these quadrants. I kind of want to explain and show you why that makes sense, okay? So when I do inverse of sine, all of them I care about quadrant 1. That's where they are all gonna be positive. So all of them I'm looking at quadrant 1 because that's where all of them are positive. Now, the negative is where things get funny because all 3 are not all negative in the same quadrant, right? Remember, all students take calculus. All of them are positive in different quadrants, which means that there's not one quadrant where all 3 trig functions are negative, okay? So let's kind of sketch a graph of my sine. So sine looks something like, I'm gonna make it go like this. Sine looks something like this. Up, down, and backwards, right? You guys all know that, correct? If you don't, it's gonna be a rough test. I'm gonna tell you that. Okay, sine is positive in the first quadrant and the second quadrant, and it's negative down here in the third and fourth. What we do is we only care about the fourth and the first quadrant of sine. If you look at this picture that I just drew, the shaded part has nothing repeated. The shaded part would like pass my vertical line test, it would pass my horizontal line test. Nothing is repeated, so it counts as a function, okay? If I go to look at my unit circle, we know that in the first quadrant, sine is all positive, sine is my y, so all of these y's are positive. And then in the fourth quadrant, all of them are also positive, or also them are all negative. So if I have a positive inverse sine, I'm looking in the first. If I have a negative inverse sine, I'm looking in the fourth. Now, there's still sine in quadrant 2 and in quadrant 3, right? However, I want just one answer. So we're going to ignore quadrants 2 and 3, and we're only going to look at quadrants 1 and 4 when I'm looking at sine, okay? So I'm looking at only at quadrants 1 and quadrant 4. That's also true for tangent. So let's sketch a little graph of tangent, and then I'll remind you of the unit circle. Tangent, which again, we're not doing any graphing transformations, but you remember what that looks like, or we learned what it looks like. I've got zeros at 0 and pi and 2 pi, and I've got vertical asymptotes at all my pi over 2s, and it looks kind of like these little cubic functions as I go across the page. All I care about is this main cubic function right here around the origin. And that, just like sine, is reflective of quadrant 1 and quadrant 4. To remind us on our unit circle, just like sine, tangent, which is y over x, is positive in the first quadrant, and it's going to be negative in the fourth quadrant because we've got negative y's with a positive x. Okay, so we only care about quadrants 1 and 4 for sine and for cosine. Or sorry, sine and tangent. I'm going to be really intentional about my words and I keep this in. So sine and tangent are both Q1 and Q4. Cosine, though, can't be Q4 because cosine is my x's. Are my x's negative in Q4? Are my x's negative in Q4? No, they're all positive. So that means we can only look in quadrant 2. We're going to look in quadrant 1 and quadrant 2 for cosine. I know some of you panicking and you're like, I have no idea what's even happening. I have to explain where we're going in order for everything else to make sense. So I have to tell you which quadrants matter before I let you loose to actually solve these problems. It's really not that hard, but you need to know that we can't go for all quadrants. So cosine is negative in quadrant 2. So in order to have a positive and a negative spot for cosine, I'm looking at quadrants 1 and quadrants 2. And again, if the graph doesn't help you, don't use it. But I think the graph is a little helpful, so I'm gonna look at it. When I draw my cosine graph, it looks something like this. If I'm looking at quadrants 1 and 4, like I looked at for sine, do you see how this would not pass my horizontal line test? All of them are positive, so that's not helpful to me. Instead, I have to readjust this, and I'm looking at just quadrants 1 and 2 to do my cosine. Just in quadrants 1 and 2. So all that I'm teaching you right now is which quadrants to look at. So when we're doing inverse of these functions, sine and tangent are both Q1 and Q4, cosine is Q1 and Q2. Okay. Now, you should have your unit circle out. Let's actually find what the inverses of these are, okay? All of my answers here should be angles because all of these have a raised to the negative first. So I gave you the ratio, you're gonna give me the angle, okay? So we're gonna go to our unit circle and I wanna know what angle has a sign that is positive √3/2. What quadrants are you allowed to look at for sine? 1 and 4. Which one is the positive one? 1. So I'm looking in quadrant 1 for where I have a sine or a y of √3/2. Where do you have a y of √3/2? Yes, but I want this in radians because that's what the direction. Pi over 3. You don't have to write down all this extra work like I did. You don't have to write the quadrants or the y. That's just helpful for me. The answer that all you really need to write is pi over 2. Okay. All right, let's look at the next one. It's also an inverse of sine, but this time it's negative. So which quadrant should I be in here? Which one? 4. 4, very good, thank you. We're gonna be in quadrant 4 because sine can only be in 1 or 4, and the negatives are in quadrant 4. So now I'm looking for a sine or a y of -1/2. Where is that?
7 pi over 4.
No. 11 pi over 6.
Oh, yeah.
We're looking for -1/2. Okay, so all we're doing is identifying an angle. You guys good so far? Okay, let's look at the next one. I've got inverse tangent of 1. Okay, tangent is y over x. So I need my y over x to be 1. What point or which angle should I be using if I want to get a tangent, a y over x of just 1? 45. Very good. My 45-degree angle. If we've done enough of these, we should start recognizing that. The only way to get 1 is to have the same number on my x and my y, which would be my 45-degree. Which quadrant am I doing for this one? Am I doing the 45 in the first or fourth quadrant? First. Good. And so what's my radian degree of 45?
Pi over 4.
Good. In the first quadrant, pi over 4. Right. All right, last one like these is my cosine, inverse cosine of 0. Cosine is which variable? X. Good, and we haven't done any cosines yet, but you have to use quadrants 1 and 2. So I'm looking everywhere in quadrant 1 and 2 to see where is my x 0. Pi over 2. And that's actually the point that's in between quadrants 1 and 2, and that's totally okay. All right. Go ahead and flip your paper. We've got a couple of calculator problems. So I'm going to get rid of my unit circle. I'm going to get my calculator out. These are just some pretty simple plugging and chugging, so that's why I thought we could kind of hit these today. The one thing I do want to mention is what mode are we in? The directions say use calculator and round to the 10,000th decimal degree. So what mode should I be in? Degrees. Whatever you want it to come out, you got to put it in. So I was just in radians because we were graphing earlier, so I'm going to go into degrees. Do you remember how to get a tan to the negative first on your calculator?
Second chance.
Second tan, so we're gonna go second tan and then type in negative 1.43. Now remember, these are answer, or the angles are my answers, so I should get an angle out from here. So I'm gonna press enter, I get negative 55.035. Now, negative 55, does that really mean a lot to us? Technically, it means that we didn't go around the positive direction, we went the negative direction 55 degrees. So if negative 55 doesn't mean anything to you and you want it to mean something to you, you can find its coterminal angle. Instead of going in the negative direction, I could go in the positive direction, which means that I would do what to negative 55? Remember one of our coterminal angles we do? Add 360. So we would add 360 and figure out what it is on the other side. And that's about 304.95 degrees. You can leave it at negative 55 if that makes you happy. We just haven't done a ton with negative, so that might feel kind of awkward. So if you would rather put it in something that makes more sense to you, add 360. That's the only one of those we'll have to do that with, okay? All right, we can do sine and secant though. So sine, we're gonna just press second sine 0.761. Perfect, I get 49.55 degrees. Or 10,000 place, sorry, I'm rounding right. 5524. Not a lot of work there to prove my point. Now this next one, secant. Okay, secant goes with which function? Which function is it the reciprocal of? Cosine, good. Now, I'm not gonna do 1 over cosine. I'm gonna have a normal cosine, but I'm gonna do 1 over my ratio. I'm gonna do inverse cosine of 1 over 1.98. You can't have a cosine that's bigger than 1. So instead, what I do is I'm gonna do inverse cosine and do 1 over that, okay? So I can go to my calculator and press second cosine. Second cosine, 1 divided by 1.98. And I've got 59.6623. Or 6653. That's why I said that weird. All right. The last type of problem I am excited to do, because a lot of these types of problems are going to be on your test that is upcoming. So even though this exact problem won't be, the skill we're about to do is very, very, very common on your test. And if you don't know how to do this, it's going to be a tough test for you. Okay. So what I see here, and again, I won't give you one like this, but as we set it up, you'll be like, oh, we've done these types of problems before. It says secant of sine to the negative first, 2 divided by 3. Okay. We have a sine, and I want to find secant. I'm going to use our quadrant angles, and I'm going to draw a triangle in one quadrant and use the fact that my sine is 2 over 3 to label that. Now, remember that sine can only be in quadrant 1 and quadrant 4. If this sign is positive, what quadrant should I be in? 1. Good. So I'm going to go draw a triangle in quadrant 1. Remember that the bottom of the triangle always has to be on the x-axis. If you hear nothing else I say today, I need you to know that the bottom of the triangle always goes on the x-axis. Do not ever draw it like this. That is wrong. I've never taught you that. Do not ever do that. Is everybody listening to me? Yeah. Okay, I cannot explain that. Like, I'm gonna be so mad if I get a test that looks like this, because you guys know better, and I know you know how to listen. Never. So it should go on the x-axis. And then one thing we sometimes forget is where the theta goes. Put the theta, put the angle always by the origin, okay? Again, there's a ton of questions like this on the test, so if you don't even have your basic angle set up, you're just doomed, okay? So make sure you know how to do this. Okay, that being said, I know my sine. My sine is 2/3. And what is sine in terms of opposite, adjacent, hypotenuse?
It's over H.
O/H, okay? So I have my O and my H, and I need to find my A. So I know my O is 2 and my H is 3. Does this start looking like a problem that we've done many, many times?
Yeah.
Good, so let's find that A, and then we can find secant. So I'm gonna do 2 squared plus x squared equals 3 squared. 4 plus x squared equals 9, x squared equals 5, x equals radical 5. Okay, perfect. When I put my radical 5 on the graph, is it gonna be positive or is it gonna be negative? It's gonna be positive. My positive,
Yeah.
I'm on the positive x's, I'm going to the right. So just kind of read your graph. It will never give you a positive or negative. At this point, you have to read your graph and see. Andrew? Yes, if you solve for the hypotenuse, you always are positive. It's these A's and O's that could be negative. All right, the last thing I want to do is just the secant. Do you remember what secant is in terms of O's and A's and H's?
It's H over A.
H over A. So I can just say my secant of the angle is gonna be 3/√5. Oh, I didn't give myself a lot of space because I gotta rationalize it. Really didn't give myself a lot of space. I'll put them down here. 3/√5, and then I just rationalize it to become 3√5/5. That's all we have time for today. I did want to get that problem because I did think that was a good review for your next test. Remember, we're testing on Monday and I do have office hours, so come get help. But I am giving a geometry test, so don't expect personal one-on-one time.